Hello Year 11, here are the answers to your 5 a day. Let me know if you have any questions about those. So today we're going to have a look at multiplying and dividing by complex numbers. We'll also need to have a look at what the modulus of a complex number is and its complex conjugate. And we'll be able to find a relationship between those as well. So we can multiply complex numbers using the same techniques that we use in algebra, and also bearing in mind that we know that I squared equals -1. So here is a binomial product. I expand using whatever method you prefer. So we get 2 times 4 is 8, 3i times 4 is 12i, 2 times 5i is 10i, and 3i times 5i is 15i squared. Write out all 4 parts. I know if you were doing this with normal algebra, you would probably jump straight to the 3 parts. I suppose you could jump to 3 terms like this, but I want to see the line with the I squared and then changing that to a -1 while you're getting the hang of it. Some point in the future, it will be okay to jump straight to an answer, but for the moment, I don't want you to do that because you'll just come across mistakes. So my -15 and my 8 I can collect together to get -7. My 22i is just 22i. Let's have a look at another example. So here I have brackets squared, so I'm going to start by writing it as a double bracket. Expand. So having the 2, you can collect the I terms together in one step, but I want to see the 16i squared, which we then rewrite as 16 times -1. And then I have 49 subtract 16, which gives me 33. Pause the video now while you have a go at question 1. And here are your answers. Now, the complex conjugate of a complex number helps us to divide one complex number by another. If a complex number is a plus bi, then its complex conjugate is a minus bi. All we do is change the sign of the imaginary part. Together, these are known as a complex conjugate pair. And we denote the complex conjugate of z by z bar. The bar is a line above the z. Please pause the video while you write down this orange box. So let's go through a few examples. 2 plus 3i, complex conjugate, is 2 minus 3i. 5 minus 2i, its complex conjugate, 5 plus 2i. 1 minus I root 5, its complex conjugate is 1 plus I root 5. Now let's have a look at some properties. I'm looking for the sum of a complex number and its conjugate and the product. So we've got z is 2 minus 7i. I need to write down what the conjugate is, so that's 2 plus 7i. Their sum, write it out properly, then collect the real terms and collect the imaginary terms. You'll see that the -7i plus 7i cancel each other out. The product, write the whole thing out, expand the brackets. You will see, and this is what we should expect, we've got plus 14i and minus 14i, so they cancel each other out. Then -49 times I squared, the same as multiplying by -1. And so I have 4 plus 49, which is 53. Let's try that in general. So if I have a complex number a plus bi, its complex conjugate is a minus bi. I add them together. You'll see that the plus bi and the minus bi cancel each other out, and I'm left with 2a. I multiply them together, expand the brackets. The plus abi and minus abi cancel each other out. The I squared is equal to -1. And so it simplifies to a squared plus b squared. Now, the modulus of a complex number is denoted by absolute value of z and is given by the square root of a squared plus b squared. As we've shown, when this product of a complex number and its complex conjugate, the product of z and z bar is equal to the modulus of z squared. This is a useful result. Please, can you write down this whole section here without as we have shown on the left? So pause the video now while you have a go at questions 2 to 5, and make sure you consider this question here when you finish question 3. And here are your answers to these questions. And hopefully what you noticed is that the conjugate of a sum of complex numbers is equal to the sum of their conjugates. And the conjugate of a product is equal to the product of the conjugates. Please write down that orange box. These results can be useful to you. Okay, so let's have a look at how we use these complex conjugates to divide with complex numbers. Here's my question. What I need to do with divisions is I start by writing it as a fraction, and then I multiply both the numerator and the denominator by the complex conjugate of the denominator. This is similar to when we rationalize a binomial denominator where we multiply. So for example, if the denominator is 1 plus root 2, we multiply by 1 minus root 2 over 1 minus root 2. So let's do it for this question here. I've rewritten it as a fraction, and I multiply by 1 minus 2i over 1 minus 2i. This is the complex conjugate of the denominator. I'm not changing the value of the fraction because I'm multiplying by 1. Write it out with brackets. Expand the brackets with their 4 terms. Collect the i's up and rewrite I squared as -1. And then simplify. I can see here, I can simplify even further because my numerator, both terms can be divided by 5, which is my denominator. So this relatively complicated looking division has a nice, simple answer. Let's have a look at a second example. Write as a fraction. The complex conjugate of my denominator is 2 plus 3i, so I multiply by 2 plus 3i over 2 plus 3i. Write it out with brackets. Expand the brackets with 4 terms. Collect the i's and rewrite the I squared as -1. Collect up the number parts. Now here, neither of my terms in my numerator has a factor of 13, so I can't simplify any further there, but it's better for me to write it into 2 parts. So I have my real part and my imaginary part. This will come in useful in later topics. Pause the video now while you have a go at questions 6 to 8. And here are your answers. Now, all of the questions that you've done today, you need to be able to do by hand, but you can do complex calculations on your CAS. So it needs to be in complex mode to be able to understand what you're telling it. So follow these instructions to put it into complex mode. Now you're in complex mode. When you ask it to find the square root of a negative number, it will do that for you. We can also do addition, subtraction, multiplication and division. Make sure you use brackets. So you'll see in this example, they haven't put brackets around the addition one because it doesn't matter. But for subtraction, multiplication, really important. Otherwise, you'll just be multiplying or subtracting one part rather than both parts of the complex number. What we can also do is get the calculator to tell us real parts or complex parts of a complex, real parts or imaginary parts of a complex number. If you just write it in as a fraction, it will separate them for you. If you type the word real rather than going through this whole list of commands and then the complex number, it will give you the real part. You can also find the modulus by going through this list of commands or using the modulus symbol, which is in the 2D template palette, or my particular favourite, just type ABS bracket. And you can find the complex conjugate by just typing conj and then bracket. So just make sure you're aware of all of those ways you can use your CAS to help you with complex number calculations. Thank you.